This is a video just to accompany the lecture notes on units and unit conversions. So why are units important? It is because units is a way to communicate the numbers we measure in sciences. I say measure because I'm an experimental physicist. I'm probably more inclined to say physics is about explore the world around us, and as such we are making measurements or observations. However, it could also be numbers you make from, say, computer models, simulations, and even from theory. They still usually use units as well. So if I, for example, go into a classroom and I want to say, how many students do we have in here? I start to say, oh, there are 50. If I just go and say to somebody like, there is 50. Well, that person will have no clue what that means. It's like this sentence is incomplete. If I then go and say, there are 50 students in my classroom, he's like, that makes sense. Now the sentence is complete. So the unit is the one that makes the mathematical or the physical sentence complete. It's the one that makes sense of the number. So that's important. What units do we use? If you go around in everyday life in the US, you use what we call the Imperial Units, like a mile, feet, inches. If you go outside the US and most of the rest of the world, they use what we call the metric units, like the meter, kilogram. So we have a set in science that we use, which we call a standard metric. We can in principle use any units that are, there's nothing wrong with using one unit over another, but it's just easier when we're exchanging numbers between groups, between people, between research groups, in textbooks, and so forth. If we all kind of have a standard, that's what we call the standard metric units. So the standard metrics that we use in Physics 1 is pretty much the kilogram, meters, and second. And then we can derive other units from it, like the Newton, which is a measure of a force. We could derive that from the kilogram, meters, and second. Similar with a joule, which is a unit of energy. We could also derive that from the kilogram, meters, and the second. Now you might think about, what about the kilometer, what about the millimeter, and so forth. Those are all metric units, but they're not the standard. Among one, so for example, meter is the standard for the length measurement, or for distance measurement, whereas kilometers and millimeter, centimeter, so forth, they're also units of a length. However, they are metric, they're not the standard. So the standard is the meter. Unit conversions, this is extremely important because when we start manipulating equations, we start making calculations, when we start to synthesize our knowledge into predictions and so forth, we use models. So for when you do homework, you use equations. You can take those as being small models, right? But when we do that, then all units pretty much have to be, or all the numbers have to carry the same units. When we do that, same standards. So we need to convert these units. One example I put on here is the Mars Climate Orbiter. It was a disaster. The Mars Climate Orbiter was designed to measure in great detail the atmosphere of Mars for future space missions, like the rovers, for example. So before they gonna shoot the rovers down through the atmosphere of Mars, they want to know something about the atmosphere. And that was the objective of Mars Climate Orbiter. Unfortunately, the software engineers and the engineers on the science team, I guess the science team, did not work in the same unit. So when they started exchanging numbers, these numbers were not converted into what they should have been. So when the software engineers got the numbers, they did not look at the units the engineers provided. So they just put in the numbers as they were given to them. And what that meant was that the models really worked with wrong numbers. And instead of going into a shallow attack angle to the atmosphere, go into a stable orbit, came in a very steep angle and burned up in the atmosphere. Okay, so how we convert units, you probably all learned how to do that, and you learn in different ways. I can ask one student, how do you convert units? So they will show it. I can ask another student, who will show me a completely different way. And the basic principle is the same though. They all come from the axioms of algebra. I cannot emphasize enough how important algebra is to sciences, whether it's physics, chemistry, engineering. If you want to take a class at some point, or you have some credits you need in your degree, take linear algebra as the first step. It's an amazing class. It was my favorite math class when I was in college. And it's just provided with some foundational understanding of math that might just make you go, wow! At least that's what I would like to think. But when you look at how you convert numbers, you might not be able to explain why this method works. And the method works because it has the foundations in algebra. And algebra is number 1. And when you take that number 1, you can take any element in your group or in your algebra, and you can multiply any of those elements by the number 1, and it will not change the element. So for example, if you look at the number algebra, if you take the number 5, if you multiply by 1, 5 times 1 is 5. The 1 does not change it, but it's still an operation. Now there's many different ways we can write 1. That's the beauty of 1. You just write it as 1. But you can also write it as 2 over 2. That's the example I gave here, or a square root of 2x or a square root of 2x. Those are all equal to 1. That also means if we start taking numbers and we know, for example, 1 meter is 3.281 feet. Well, if we divide by 1 meter on both sides, that means we have 1 meter divided by 1 meter. That is 1. So that means that we have 3.281 feet divided by 1 meter is equal to the number 1. And that's really important. We can also go the other way around to get 1 meter over 3.281 feet. So that's the number 1. So here's an example I give here. So let's say we had 2.6 meters. I'm going to convert that to feet. So we're writing 2.6 meters. Okay, that doesn't give us anything. But I'm going to multiply by 1. Because I know by multiplying by 1, I'm not changing anything. So 2.6 meters times 1 is still 2.6 meters. But from the above, I know I could write 1 as 3.281 feet divided by 1 meter. So I'm going to write 1 like that instead. I know it's not going to change my answer. It's going to be exactly the same. So I can now separate out numbers. I can separate units. I'm going to treat the numbers from the algebra I know, how you do multiplication, division, and so forth. But I'm going to treat the units exactly the same way. I'm going to treat the units as if I could just multiply and divide by them. Okay? So now we have 2.6 times 3.281. That gave us 8.5, taking into account significant figures, because we're giving a number that's 2.6, which only have 2 sig figs. And then we have meters times feet divided by meters. Well, that's feet. So 8.5 feet. Voila, we're done. We have now 2.6 meters is equal to 8.5 feet. And we did that by multiplying by 1. And of course, there's many ways to multiply by 1. So the key here to when you do the unit conversion is to find out how do you write 1 in a suitable way that can help you to convert your units. So in the last step here, I just have a box for you guys to try out. Convert 3 feet to meters using a similar approach.